Friends, I am Dr. Lalita S. Kumar from the chemistry discipline of School of Sciences, and I would today introduce you to a new course from the School of Sciences which has been prepared and offered from the chemistry discipline, and that is environmental chemistry. When we talk of environment, we think of in terms of pollution and number of global issues associated with it, and environment in fact has become a global phenomenon. And for this particular course, we don't want to focus our attention only to the pollution issues, but to understand our environment in such a manner so that it gives us the chemical phenomena going on here. And from a chemist's point of view, we should know what is the constitution of our environment. Until unless we understand what exactly our environment is, we won't be able to tackle all those global issues which have become a hot topic nowadays. And in fact, everybody is aware of all these. And this course has been prepared keeping in view all those points in mind, so that you can also, after understanding this course, maybe in a position to contribute in the improvement of our environment. So if we look into the objectives of this course, this course signifies our natural resources. After studying this course, you will be able to very well appreciate we have a real mine of number of natural resources. They are in the form of water, air, soil, and many more. But for this particular course, we would be focusing on these three main components. You will be able to appreciate, after reading through and going through all the units, how important these natural resources are. And if we don't exploit them in a proper fashion and manage or conserve these natural resources, we are going to land up into a number of problems. So the very first aim of this particular course is that it gives a significance of all our natural resources. Then we are taking into consideration the three main components, which is soil, water and air, and we would be dealing with all the chemical constituents. Basically, because as we see, it is not what we really see. It has much more inside. Like water is just not what we see as a plain transparent liquid. It has many more components in it. So we would in detail see what are the constituents of all the three components of our environment. And then it is very important what we are consuming, what we are making use of from our environment as a natural resource, how important it is very important to see what is the quality. Suppose we are drinking water. Is this water really fit for drinking or not? Or suppose it is soil. Is this soil fit for agriculture or not? I mean, all these factors need to be considered, and for maintaining quality of all the components, we need to work. We need to understand what is required to maintain the quality, and first of all, what are the quality parameters. So our aim is to define all those quality parameters also, and not only from just from their chemical constituent point of view, but their legal point of view has also been considered in this particular course. So with all the components, you'll come to know of the legalities and I mean the statutory bodies which are involved in defining the parameters, the quality criteria, standards, and of course their monitoring. And of course, I think when we think of environment, we think only in terms of pollution, and it becomes a must. If we are offering a course in environment, we have to consider the pollution aspects. So the pollution aspects related to all the components have been dealt in great detail. What are the various pollutants present in water, soil and air, and how to basically tackle these pollutants. Well, I would just tell you the salient features of this particular course. As I said in the beginning, it is an application oriented course, and most of the application oriented courses in IGNOU are 8 credits or 4 credits. So this course also is an 8 credit course. The only difference being, like from our school, we have a few more application oriented courses related to environment, that is we have human environment also. So we have 6 credits total of theory in this and 2 credits of lab. These 6 credits we have got 6 blocks for the 6 credits, and they carry the content of this particular course. One block is devoted to the laboratory work, which is worth 2 credits. So the distribution, it is from the blocks point of view. For this particular course, we have, we've dealt with both the things. We have taken them as a concept of chemical phenomena and then their pollution aspects too. And I think all of us would agree, our greatest natural resource on which we are really thriving and surviving is soil. Soil, when we say soil, we don't exactly mean what only for the sake of living or staying on it, but then soil means a lot more to us, and it is not only what we see as a top layer of the soil. There is a whole depth of this soil, and our soil, this natural resource also, it did not come like this. I mean, it took billions of years for this soil to come to a stage where we could really exploit all its goodness and then prepare it for the sustenance of life. Today, all life forms, be it human beings, animals, or the microbes also, all of these, they are able to sustain life because of this soil. It gives us the food, the crop which we are able to consume, or indirectly all the living beings and the ones of course who are living on it. So the very first block of our course is devoted to this component of environment, that is soil. And here, since the basics of soil, we should first know what is the nature of this soil in our first unit, which is the nature and formation of soil. It gives a good account of the nature, the various components, and as I said, it is just not what we see as the top layer. It has a number of layers inside, and they are defined on the basis of their chemical constitution. And then of course, how has it formed over so many years by processes of disintegration and decomposition of minerals and rocks, and it gives a real interesting detail of that. The second unit of this particular block is related to the quality parameters of soil. Now the soil is not same for all places, from one place to other, from one city to other, or for that matter from one country to other, it differs. The soil which we have at Delhi, maybe it's so different from what we have in Rajasthan. The texture, the constitution is very different. It varies from place to place, and we know that agriculture is our mainstay also. So the second unit is details about all the quality parameters related to soil. Then the last unit of this particular block deals with the soil fertility and productivity. As I was saying, since the whole lot of a good part of our country depends a lot on agriculture, and for that matter maybe many other places too. So we need to know how to make the soil fertile and productive, fertile to give the maximum production. The two terms are differentiated very well in this particular unit, and availability of the nutrients, because the way we need the nutrients, our soil also requires for the plants, the vegetation which grows on it, it also needs all kinds of nutrients. So a whole lot of macronutrients, the microbial population, etc., has been dealt in this particular unit, and it gives a good detailed account of all that. It shows that our soil is not exactly as I was saying what it appears, but we have to take a three-dimensional view of this soil and then view it. For that, actually the soil is really dug up in such a manner that it gives a three-dimensional piece to us, which is called as a pedon, as you can see in this particular slide. And this pedon, if we see and carefully, and there are number of layers which are called as soil horizons. We have a number of these soil layers, and we divide them into soil horizons, which are named like O, A, E, B, and these are differentiated on the basis of their chemical composition. Some of them contain more of organic matter, some of them contain more of inorganic matter and other things also. As I was talking about the second unit of this particular block, that is about the soil quality. The soil quality depends upon a number of factors. We have a color of, we have different colors of soils also, and different types from their texture point of view. And the color also, as is given in the unit also, a Munchel chart is used to define the color. And besides that, USDA, that is United States Department of Agriculture, has given a laboratory method to define the texture of soil. Now the soil can be so different. It can be totally sandy like a Rajasthan soil, or it can be so it can have a lot of clay or a lot of silt, or it can have a good proportion of all these three. Now this triangle, as you are seeing in this particular slide, it shows the composition of these three components in soil, and accordingly we can give a name to the soil. Like in this you can read, we have clay soils, we have clay loamy soils, we have sandy soils or silt loamy soils, etc. Our second block of this course is devoted to water, and the very first unit gives a detailed account of all the water resources which are available with us. The natural resources of water, we get water from rains, rivers, and then of course groundwater is also available to us. The second unit of this particular block is related to the water characteristics. I was talking water as such, for a layman, it is just a glass of a transparent looking liquid, nothing else. But if we look into the characteristics of water, it has both physical as well as chemical characteristics. The water also has color, it has odor, and it has turbidity. At places where water may not be very clean, we can see turbid also. Then it has the chemical characteristics, or the chemical composition of water includes many components, like its alkalinity, it has some pH, it has acidity because of many sources from where acid comes into water, it all gets into the main resource. So it has pH also. Then it has dissolved oxygen in it, and that in fact it is very important. Until unless there is some oxygen which is dissolved in water, the aquatic plants as well as aquatic animals would not be able to survive. So water is so crucial, and it has such properties which again are very crucial for the sustenance of life forms on the globe. And the third unit of this particular, as it is for all the units, the third unit deals with water quality criteria and uses. As I was saying also, the water we consume is whether it is fit for drinking or not is decided by the water quality. What is the minimum drinkable criteria, or what is the criteria for giving water to the plants, or for recreational purposes also, or for that matter for making use in industry too. So all this needs to be defined by the water quality criteria, and then of course the number of uses after that it has. This is just again another diagram from the block which shows the hydrological cycle, where we can see, as you can see in this particular diagram, how does the how does water go up to the atmosphere and then come back to the ground and replenish its resource. This is the natural way of having this resource on our earth. It goes from the oceans, evaporates, forms the clouds, and again after oversaturation it comes back to the earth in the form of precipitation, or what we call in colloquial terms we call rain. So this is the way the hydrological cycle is very important for us. And this is one diagram again from the block which shows the I think you may some of you may be familiar also with this water harvesting procedure, and in fact it has been the government has also been making efforts and has been advertising to each and every place to harvest water. See, with the growing population, especially in our country, we know that the consumption of water has really gone up. In spite of having a good resource of water in the country, we are not able to provide water to in sufficient amounts. I think every day we face all these problems of water, and as say ideal citizens of our country, we should be able to conserve water, and not only conserve, we should see some means to harvest also. And this particular diagram also shows one way of harvesting the natural resource of water, that is rain. How can we collect this rainwater and make use for different purposes? And this is the way we can really think of kind of making a proper use of this particular natural resource and not losing it completely. Well, it is said that you can live for many days without food, and for say very few days without water, but can you really live for a few minutes also without oxygen? I think not at all. Everybody would agree it's so difficult. Even I think maybe some people who are observing yoga or something like that, they may be able to hold their breath and do without oxygen, but most of us cannot hold it even for a few seconds. With that, I think atmosphere becomes very important from 2 points of view. One, it gives us the life gas, that is oxygen. I think needless to say about that, everybody knows the significance and importance of that particular gas. Besides that, environment is becoming a global phenomenon with the great, I think we are aware also, the greenhouse effect and the ozone layer depletion phenomenons. These two phenomenons have, and I think like maybe water is not able to travel from one country to the other or from one continent to the other with that speed or with that pace, but essentially atmosphere is one thing which is all around our globe, and it is one and the same for all of us. Maybe we think that the developed countries, maybe they have better resources, but in terms of atmosphere, I think all of us globally need to be very much aware of our atmosphere, especially with the industrialization, modernization, increasing population, and making use of the latest with the different kinds of instruments or such equipments which are releasing, or motor vehicles also, which are releasing so much of noxious gases which make our environment totally polluted. I would like to just go back a little to the first two blocks and tell you that those two blocks dealt with the basic constitutional part of those two components, water and soil, where only their constituents and their composition was dealt in a broader sense. but their pollution has not been dealt in those two blocks. It comes later, but for atmosphere, this block is complete in itself, in the sense that it first tells you about our the nature of our importance, its significance, the various constituents, and it also deals with the pollution part. So whatever the pollutants in atmosphere, or how are they being dissipated, etc., is dealt in this particular block. And the first unit of this block is dedicated first to understand the nature and significance of atmosphere. We should know what do we have all around us in the form of air. We call it only air, but then what are the various constituents, and what is the significance of all those constituents. And this particular unit also gives a detail of the global phenomena which I just mentioned, that is the greenhouse effect and the ozone layer depletion, which is again becoming a global issue. And then see, this atmosphere of ours is greatly affected by the meteorological factors. The meteorological factors like rain, humidity, temperature, wind, both wind direction as well as the wind speed, they all matter, as I was saying, because it's difficult maybe to let the water from one place go to the other so easily, but then you cannot stop air to flow from one direction to the other, and this speed makes the pollutants from one place go to the other one, and in that process, not only if one place is polluted, the other automatically gets polluted. And meteorological factors, which I was mentioning, are very important in deciding all this. So the second unit is dedicated to the meteorological aspects of air pollution. Here I mean all those factors which are related to the factors like temperature, how does it affect, how does it vary with height or with latitude, or how does the wind speed and wind direction affect. And then one is supposed to be knowing while setting up an industry, where how should one look into these factors and accordingly set up the place for an industry. You cannot do it just maybe at the center of the city, which will pollute the whole environment. And the third unit of this particular block gives a good idea of all the air pollutants, the pollutants which are present in the atmosphere, which every day, every minute, every hour we inhale, and maybe over the years the diseases have increased because of this problem only. We are inhaling so many toxic gases like carbon dioxide, nitrogen oxides, sulfur dioxide, etc. Therefore, I mean, keeping the severity of this pollution problem of the atmosphere, it becomes very necessary to monitor. And like we have in India, we have Central Pollution Control Board, which takes care of the monitoring part of atmosphere, where it monitors what is the existing level of pollutants, what it should be actually, and how to minimize it. And it gives, in fact it is done on yearly basis, it gives whole data also, because they keep monitoring it, and this monitoring is to be done on hourly basis, 8-hourly basis or 24-hourly basis too, and not only once or twice, it is to be done maybe the alternative day of the week, weekly, like this. So a proper monitoring is done to think of the control measures also. So in this particular unit, we've dealt with the monitoring aspect, which defines very broadly the air qualities, the indoor and the outdoor air qualities, and then their monitoring and also some control measures. Well, in this slide, this shows, as I was talking about the first unit, it tells you the layers of atmosphere, and I hope we know that our atmosphere is not only it is not only a few kilometers. In fact, it extends to 600 kilometers and above. but then the meaningful atmosphere is not that beyond, maybe the one which is around say 6 kilometers, and depending upon temperature there are different layers which have been specified for this atmosphere, and we name them as it is shown in this. I think technically this particular slide looks quite catchy. It looks very nice, but I think we can by just seeing this slide we can imagine the severity with which the industries are causing pollution and giving rise to lots of all those gases which are a potential reason of the acid rain. We've given this particular phenomenon of air pollution, where we've talked of air pollution, we've talked of acid rain, which is formed because of the polluting gases which are coming out of these industries, and along with rain they come out in the form of acids, the carbonic acid, nitric acid, sulfuric acid. And not only that, with that it first of all it falls on ground, thus it deteriorates the soil, the groundwater, it causes a problem to us also, and in that manner it is in a multiple way it is causing harm. And as you can see, this particular slide shows the formation of the rising of those gases from various industries and then coming down in the form of acid rain. Well, this particular slide, this is just the last part of our block, that is about the monitoring and control. It is a device which is used for monitoring of atmosphere, the air component. This is called as a high sampler device, which is used to collect the samples, because we've dealt with the last unit deals with the monitoring details of some of the gases. So this shows that how we collect air samples through this high volume sampler. This particular block, that is block 4, deals with the pollution related to soil and water, and gives a detailed account of the pollutants in soil and water. Here it does not only tell about the pollutants in particular, but it gives a detail of the sources from where soil and water get pollutants, and then it gives the causes of this pollution and some remedial measures. The first unit gives an account of the industrial effluents. In that context, a number of industries have been taken into account in this particular unit, like we have petrochemical industry, textile, tanneries, and then many more industries which are the causes of basically the soil and water pollution. The effluents from these industries either go into water or go into soil and trickle down to the groundwater finally, and then it gives some control measures too. So another source of soil and air, this water pollution, is agrochemicals. In the process of improving the quality of our crops and improving the agriculture, the modern technologies make use of pesticides, insecticides, weedicides, etc., and all these are chemical based. So no doubt that they improve the crop, but in that process they contaminate our soil, and all these pesticides indirectly then, because they come to the plants, and through plants the consumers, that is the animals or human beings also, they indirectly get all these pollutants into themselves. This is and are very harmful and have very health negative effects on human beings as well as animals. So this is about this deals with pesticides, and also in fact the fertilizers and manures, they are also sources of soil pollution. Another source of soil and water pollution is the municipal and domestic waste, and this particular unit gives a detailed account of mainly the sewage waste which comes from the domestic sources, and it also gives along with of course this sewage, which is a major cause of this pollution, it gives a detailed account of the plants which but make use of this sewage, called the sewage treatment plants, through which we can treat the water which is a waste from the domestic sources and can be used for irrigation. And then finally, of course, this particular block deals with the major effects of soil and water pollution on various human beings as well as animals and other living beings. This slide shows how water is getting polluted. I mean the effluents from industry are getting into water, spoiling the whole big source of water, and which is consumed by again number of living beings which are living in water or on land, or human beings or animals. Well, I was talking about the monitoring part of all the environmental components, and monitoring has to be done by means of some procedures. So this particular block, that is block 5, deals with the non-instrumental methods of analyzing all the pollutants. The non-instrumental methods basically are they are the conventional and the classical methods, and I think if you've gone through the 3L lab of our program, you may not be unfamiliar with the procedures, with the apparatus which is being used there. You've done a whole lot of quantitative analysis there. Here again, these instruments are used for qualitative as well. These non-instrumental methods are for qualitative as well as quantitative methods, and you already have a good idea, but then still we've given a good detail of these non-instrumental methods here. And this particular block starts with a unit on sampling techniques and preservation. Sampling in the sense of all these components is very important, because all of these are difficult to it's difficult to collect their samples, especially the air. We don't know how to collect air and then do its testing. So knowing sampling procedures becomes very important, and this particular unit gives a detailed account of that, and how to preserve it for some time. Suppose you've not done the analysis for that particular moment. As I said, it deals with the classical techniques of volumetry and gravimetry. So volumetric experiments you've done a number of titrations, those are volumetric titrations, and then there is gravimetry also. If you've done 7L, that is an organic lab, you may not be unfamiliar with that particular procedure also. It is by precipitating the particular pollutant and then taking the weight of it. Then we have another classical techniques, that is solvent extraction and chromatography. Chromatography is a separation technique. Solvent extraction is also a separation technique, through which you can even separate a liquid sample. These are the volumetric and of course the non-classical, as I was saying, instruments. Well, the last theory block of this particular course relates to the instrumental methods of analysis, and here these methods exploit the physical property of compound. So basically here we have 3 techniques. We use 3 types of instruments. We have electroanalytical methods, we have optical and microbiological methods. Electroanalytical methods exploit the electrical property, and you will make use of a pH meter, a conductometer, a potentiometer here. And optical methods, here you will be using, if it is available in your study center maybe, then the spectrophotometer. And we've given a few experiments based on this particular method. Well, this gives you just a picture of the spectrophotometer, which maybe you will be using, or if it at all it is available at your study center, or may not be using. Well, the last block, as I was saying, this particular course is well integrated with the practical aspect. So the last block is dedicated to the experiments. It gives you a whole account of all those experiments which are to be done over 7 days of this lab work. It is a 2-credit course, and it has to be done over 14 sessions. Like we have divided the theory course into 3 main components: soil, water and air, atmosphere. So here also the demarcation is more or less like that. There are analytical experiments which are based on the water samples, the soil samples and the atmospheric air samples. This particular slide shows you the diagram of we call it a sampling train. This is basically, you will make use of all this when you do the experiments for air pollutants. You will learn how to collect air sample and then how to analyze it for the further pollutants like sulfur dioxide, nitrogen dioxide and so forth. Well, very briefly I would tell you the assessment part of this particular course. Like all other, you may be familiar also, since you have gone through number of these courses. The theory assessment has 2 components, the continuous as well as the term end. And for this particular course we have only tutor marked assignments. There are 3 assignments. The first assignment is based on blocks 1 and 2. The second assignment for 3 and 4, and 5th and 6th block have the 3rd assignment. So in all you have to do all the 3 assignments, which will be evaluated for 30% weightage of the whole evaluation part. The term end evaluation will be, since it is a 6 credits theory part, so you will have a 75 marks exam which will be done at the end of the after you have gone through the whole theory part. And the laboratory work, maybe you are again familiar with the assessment of this part. You have 2 components, guided as well as unguided. The guided part has 70% here. It is just the reverse, 70% of the weightage, whereas the unguided has 30% of the weightage. I think this is all about this particular course. I hope you will really enjoy reading this particular, because this is so relevant not only from your point of view, but rather in also your contribution to the environment as a whole, and we hope you will really enjoy reading this particular course. Thank you.